Good afternoon, class. We are looking at Module 3, Practice Test 3 for College Algebra, covering Chapters 5 and 6. Chapter 5, Polynomial and Rational Functions. Chapter 6, Exponential and Logarithmic Functions. And now we are going to look at Chapter 5, Polynomial and Rational Functions. So the price-demand function of a company that manufactures with a large tank or tub used to hold liquid is given as P of x equals minus 5x plus 600. We want to find the revenue function. The revenue function is the number of units times the price. Normally, x represents the number of units. So x times P of x, lowercase p of x, their product will be minus 5x times x minus 5x squared plus 600x. The company's fixed monthly cost is $1,563, and each unit of bets costs $10. Write the cost function C of x, where x represents the number of packets of bets produced. Well, it's just remember y equals mx plus b. In this case, C of x is mx plus b, and this is a fixed cost, that's your b, and this is a variable cost, that's your m. So 10x plus 15, C of x is 10x plus 1563. Find the profit function. This is uppercase P, this is lowercase p. Simply put, as you recall, it's the revenue minus cost. So revenue is 5x minus 5x squared plus 600x. C of x is 10x plus 1563. We're going to subtract from it. Therefore, we are going to distribute the negative sign. Minus 10x is 1563. So we can combine these two into 590x. The rest do not change. How many bits must be produced and sold in order to maximize profit? So what do we notice? We notice this is a quadratic function, QF short for quadratic function, where A is negative 5. The idea is negative. What does it mean? It's a parabola that opens down. When the parabola opens down, then the maximum occurs at its vertex, x equals minus b over 2a, where a is negative 5, b is 590. So minus b, which is 590, over 2 times a, which is negative 5, and we end up with 59. What is the maximum profit? So we go back to the profit function that we found, and we replace the x with 59. So we get minus 5 times 59 squared plus 590 times 59 minus 1563. When we put them together, we get $15,842. What price must the company charge in order to maximize profit? We go to the price function, which is minus 5x plus 600 minus 5 times 59 plus 600 will result in 305. The polynomial of degree 3, P of x has a root multiplicity 1 and x equals minus at x equals minus 6, and a root multiplicity 2 at x equals 4. P of x passes through the point 2, comma 8. Find a formula for P of x in factored form. Well, P of x is a polynomial, okay, of degree 3. So we start with some coefficient to begin with, such as a. And then this means x plus 6. This means x minus 4. Multiplicity 1, that means x plus 6 as the exponent 1. Multiplicity 2 means x minus 4 has exponent 2. So again, this results in this. Multiplicity 1, that means the exponent. If I were to put the exponent, I would put exponent 1. This means x minus 4, and then multiplicity 2 gives us this. And why a? Because we don't know what is this polynomial. Now, the last thing is to use the given pair 2 comma 8 into this. Now 2 replaces the x. 8 replaces the y or p of x. Remember, this is the y or p of x. So replace the x with 2, and we get 8 here. This is negative 2. When you square negative 2, you get 4. So 8 times 4 times a. Negative 32a is 8. Divide by negative 32, positive 32, because it's minus 2 quantity squared. Divide by 32, and we get 1/4. And now we are going to write this function. Now, in some cases, that's good enough. In some cases, they want you to multiply them out. So just follow the instruction for full credit. Divide using synthetic division. So we have 3x cubed minus 2x squared plus x minus 4, and 1 divided by x plus 1. Now, everybody remembers long division. You can simplify it to a synthetic division if the divisor is x and some number, x plus 1, minus 1, any number. Now, you are going to do the synthetic division as follows. We are going to just write those coefficients. In the case of a synthetic division, we write every coefficient, and if anything is missing, we have a place value of 0. So for example, this is 3, we write it. This is minus 2, we write it. This one as plus 1, but if it were missing, you would have to put 0. And this is minus 4. Now, because we are dividing by x plus 1, we are going to use negative 1 here. So we basically set this up. And this comes from here. Now, when you divide by x minus k, then you use k here. Meaning, if I'm dividing by x minus 5, I will use 5. If I'm dividing by x plus 5, I use minus 5, and that's exactly what's happening here. So, in the case of a synthetic division, we drop the number, just the first number, a, whatever it is, it happened to be 3. Then we multiply this by this number. So the way we are going to write it is with this arrow, and we multiply it by negative 1. We get negative 3. We add these two numbers. It gives us negative 5. We do this one. We multiply by negative 1, gives us positive 5. We add these two, and we get 6. We do the same thing times negative 1, and we add these two, and we get negative 10. Now, please bear in mind, the degree is 3 here. The degree is 1 here, so the result is the degree goes down by 1. So this means 3x squared. This means minus 5x. This means just plus 6. And this is your remainder. So that's what we write. 3x squared minus 5x plus 6. Now you can say this is the remainder. One way to write it is plus and write the sign divided by x plus. The other method you could write, it depends on how they want it. You could write the following. 3x cubed minus 2x squared plus x minus 4. The dividend is the divisor x plus 1 times the quotient 3x squared minus 5x plus 6, and the result, we add the remainder. This is the remainder, including the sign. So this is synthetic division. Consider the function f of x equals to x cubed minus 8x squared plus 5x plus 3. List all possible rational zeros of f, the function f. And I remind you that rational zeros are found by dividing factors of a sub 0 over factors of a sub n, where f of x is a sub n, x to the power of n, all the way down to a sub 0. A sub n is the coefficient, is the leading term coefficient, okay? And this is a constant, okay? So in this case, a sub n, more specifically a sub 3. Why a sub 3? Because the exponent is 3. A sub 3, the degree is 3, is a 2, and a sub 0 is the constant 3. Therefore, we have factors of 3 over factors of 2. As you know, factors of 3 are just plus, let me just write them at top of it. Plus minus 1, plus minus 3. For 2, plus minus 1, plus minus 2. So what we do, if we divide these two, we get plus minus 1. We divide these two, we get plus minus 3. If we divide these two, we get plus minus 1 half. These two plus minus 3 halves. So I hope you see what happened here. So there are 1, 2, 3, 4 times 2, 8 possible zeros, rational zeros. We are not saying that they are the zeros, because the zeros, rational zeros, maximum could be 3. Therefore, not all of them can be the zeros, but those are possibilities. Now, if you want to find rational zeros, then you evaluate, you use the remainder theorem. You plug in positive 1 half, negative 1 half, positive 1, negative 1, so on and so forth. Whatever that gives you 0, that is a factor. For example, if we plug in 3, and I'm not going to go through all of them, f of 3, you get 0, because you get 2 times 3 cubed minus 8 times 3 squared plus 5 times 3 plus 3. You can work it out, it becomes 0. So 3 is a rational zero. That means this function is divisible by x minus 3. That's the meaning of it, okay? Find the remaining zeros, okay? So we prove that it's divisible by x minus 3. So instead of checking all of them, and you can continue checking, you can continue checking. If we do the division, because this is degree 3 and this is degree 1, the result will be degree 2. And degree 2, we can use the quadratic formula. Again, I want to make sure everybody understands that you can continue with this process. So we got the rational 0, 3, okay? And we are going to take it from there. And by the way, because the degree is odd, we have at least one rational 0. It could be that all of them are rational or just one of them. Now, the rest of the zeros, if they are not rationals, if they are irrational or complex, they happen in pairs. So I just showed you how to do this division in the previous page as far as the synthetic division is concerned. I'm going to quickly show you again. So I'm going to use 2, -8, 5, and a -1 first. So 2, -8, 5, -1. And since I'm dividing by x minus 3, I'm going to put +3. So I'm going to drop the first one just the way it appears, 2. Then I'm going to multiply by this number. I get 6. I add this 2. I get -2. I'm going to multiply again by 3. Gives me -6. Add them up. I get -1. I will multiply this by 3 again. Okay, first of all, why did I put -1? Okay, so I go back here and fix something, everybody. So this was +3. Okay. So when I multiply it -3, because I was supposed to get a 0 here, it didn't happen, and I was surprised what happened here. All right, so take a look. This is exactly what we get. Now, this is a quadratic function, and I can use quadratic formula on that. So let me erase everything. And again, this one is +3. All right, I'm going to use the quadratic formula. Minus b plus minus a squared of b squared minus 4ac over 2a. So a is 2, b is, let me write it. So according to this, a is 2, b is -2, c is -1, and we are using x equals minus b plus minus the square root of b squared minus 4ac over 2a, resulting in this. And so we have a 4 plus 8, which gives us 12. And as you can see, this is a 4 times 3, or simply 2 square root of 3. And I can write this as 2 times 1 plus minus square root of 3 over 2. The 2's cancel out. That's the final answer. Now, how do we write this in factored form? This was 3, so x minus 3. This is 1 plus square root of 3 and 1 minus square root of 3. For 1 minus square root of 3, we put minus 1 minus square root of 3. And so, of course, if you want to distribute this, you get -1 plus square root of 3. In this case, you get -1 minus square root of 3. But that's good enough because that's the way they want you to write it. And I wanted to remind you of this synthetic division. All right. Here's the function. X to the power 4, f of x equals x to the power 4 plus 2x cubed plus 22x squared plus 50x minus 75. We want to find f of 1 and remember the rational zeros. So we put 1. If you put 1 to the power of 4 plus 2 times 1 cubed plus 22 times 1 squared plus 50 times 1 minus 75, you end up with 0. Okay. And that's easy to see. 1 and 2 is 3 and 22 is 25 and 50 is 75 minus 7. If you plug in -3 and I leave it for you to evaluate that, you also get a 0, which means 1 is a 0 of this function, or this function is divisible by x minus 1. -3 is a 0 of this function, and therefore x plus 3 is a factor of this function. So if we were to use rational zeros, we would get factors of this over factor. This was plus minus 1. And all you have to do is write factors of 75 or -75, which are plus minus 1, 3, 5, 15, 25, 75. So if you were to use a technology, you can graph second calc 0 or try 1 by 1, and you get -3 and 1. And you can see this part if you go to the last module in Canvas. I have the information for technology, for TI calculator. Now, if 5i is a 0 of the function, find the remaining zeros. Now, let's go back to it. First of all, the degree is 4. There are 4 zeros. We already have 2 of them. And 5i is a 0. What happens? We have the conjugate zero theorem as follows. If p of x is a polynomial with real coefficients, and if r equals a plus bi is a 0 of p of x, then its conjugate, a minus bi, we call it the conjugate r bar. A minus bi is also a 0 of the function. So because this is 5i, by the way, the real part is 0. For example, it's not 2 plus 5i, it's just 5i. So the answer is -5i. And so if we were to rewrite this using factor format, we get f of x equals x plus 1 times x minus 1 times x plus 3 times x minus 5y times x plus 5y. So in some order. And what matters is that this part we should recognize it as x squared plus 25, because it's x squared plus 5 squared. Find the domain of the following function. Express your answer in interval notation. As you recall, domain, we set the denominator equal to 0 because we are dealing with a rational function, and we exclude that. So when we set this equal to 0, we can see the factoring x plus 2x minus 4, because you want two numbers, the product is -8, the sum is -2. So x is either -2 or +4. And those are the ones that we have to exclude. So in other words, the domain is all real numbers except these two. How do we write it in an interval notation? -∞ to -2, union -2 to 4, union 4 to infinity. All of them take parentheses. Use the remainder theorem to evaluate this function. Basically, the remainder theorem says plug in 2. So what happens is, if the result is 0, then x equals 2 is a 0. That means x minus 2 is a factor. If it's not, just whatever the number. So let's plug in number 2 and evaluate. So 6 times, this is 16 minus 8 minus 15 times 4 plus 4 minus 7. So this is 96. This remains as minus 18. This is minus 60. And 4 and minus 7 remain. So when you put all of them together, you get positive 25, which means x minus 2 is not a factor, which means if we were to divide this function by x minus 2, the remainder would be this. So how do you find this remainder? You have two ways. You do the actual division or use the remainder theorem, which means evaluate, and it's a lot easier. Show that x plus 2 is a factor of this function x cubed minus 6x squared minus x plus 30. Find the remaining factors. Okay. First and foremost, if this is, well, the remainder theorem, that means if this is divisible by x plus 2, that means you have to evaluate it at negative 2. Okay. So f of negative 2. So negative 2 cubed minus 6 times negative 2 squared minus negative 2 plus 30. And when we do that, this makes it negative 8. This makes it positive 4 times negative 6 minus 24. And then we have plus 2 plus 30. As you can see, they add up to 0. Now, we want to use the factors to determine the zeros of the polynomial. To find the rest of the zeros, it's very easy. Just divide by x plus 2 by any means. You can do long division, or now we know synthetic division. So if you go through the synthetic division, you drop in the 1, you multiply this by negative 2, you get negative 2, you multiply this by negative 2, you get 16, and then you multiply this by negative 2. And of course, you do expect the 0 as a remainder. And what happens is that you can write this now as the product of x plus 2 and x squared minus 8x plus 15. And this can easily be factored. You want two numbers, the product is 15, the sum is negative 8. We have negative 3 and negative 5. So by the factor theorem, we proved negative 2 was a factor. X plus 2 was a factor. It was divisible by negative 2. Therefore, it's divisible by 3 and divisible by 5. So the zeros are negative 2 here, positive 3 here, positive 5 here. Given the function f of x equals x plus 4 over 2x squared plus 11x plus 12, find the domain of f in interval notation. Remember, the domain is basically set the denominator equal to 0 and exclude that. We notice we can factor this because we need to find the zeros. And of course, what happens is that this cancels this one. And it simplifies to what you see here. However, this has some differences with this expression. And that is, this expression has no problem at x equals negative 4, but this expression does. Therefore, you can say f of x is this as long as x is not equal to negative 4. So the domain would be to not only exclude negative 4, also set this one equal to 0, you get negative 3 halves. So 2x plus 3, let me just write it. So if you set this one equal to 0, x becomes negative 3 halves, and that must be excluded. And this is the way you write. The domain is negative infinity to negative 4, union negative 4 to negative 3 halves, union negative 3 halves to infinity. when we do rational functions, we have asymptotes, we may have holes, and we have to consider all of the above. So, speaking of a hole, when you compare these two, what is the difference? This one doesn't have a hole. This one is the same thing with a hole. At what point? At x equals -4. So you can't evaluate this at -4, but you can evaluate this at -4. So if you plug in -4, you get -4, 1 over 2 times -4 plus 3. This makes it -8 plus 3, makes it -5, 1 over -5 or -1/5. The hole has this location, -4, -1/5. That's in the rectangular coordinate system. That's the pair. So that's the point. If this may not be to scale, but you go with 1, 2, 3, -4 and -1/5. Remember, this is 1. Okay, so the scale may or may not be the same along the x and y axis. So if this is 1, meaning -1, so -1/5 is 1/5 down, okay, between these two. So that there is a hole there. All right, let's discuss vertical asymptote. Vertical asymptote, you set the denominator equal to 0, x equals -3/2. Not this one. You can't say x equals -4 is a vertical asymptote because that's a location of a hole. So what about the horizontal asymptote, oblique asymptote? Let me, so that is the vertical asymptote x equals -3/2. This is -1, this is -2, so x equals -3/2. Here's the way we find asymptotes. If f of x is n of x over d of x, and we write it out, the degree for the numerator is n, the degree for the denominator is m. If n is less than m, the horizontal asymptote becomes y equal to 0. In fact, right here, the degree of the top is 0, the degree of the bottom is 1, and that's exactly what's going to happen here. Horizontal asymptote will be y equals 0. If n and m are identical, then the coefficients take over. A sub y equals a sub n over b sub n. If the degree of the numerator is larger by too much, we don't have anything. But if it's larger precisely by 1, the difference is 1, we have an oblique asymptote or slant asymptote. We divide the top by the bottom. It gives us a linear function with a remainder. The linear function, y equals the linear function, is the equation of a line which is some sort of an oblique asymptote. So with that being the case, the horizontal asymptote y equals 0 because the degree of the numerator is 0, the degree of the denominator is 1. So it's just, remember, y equals 0 is simply the x-axis. Find the intercepts of f. X-intercept and y-intercept. X-intercept, you set y equal to 0. Y-intercept, you set x equal to 0. So x-intercept there is none, y-intercept 0 and 1/3. Let's see why. How do we find the x-intercept? We set the y or f of x equal to 0. A fraction is 0 when the top is 0. So you set the top equal to 0. But the top is a number. It doesn't matter positive or negative, small or large. Can't be 0, it's just a number. So x-intercept does not exist. We don't have it. But what about the y-intercept? You set x equal to 0. If I set x equal to 0, I get 1/3. That means 0, 1/3. So this is 0, 1/3. Okay. This is the axis class. Let me just do this to make it easier to understand. So we have, okay, these are the axes, okay. locate at least 1 point on each side. By the way, if you were to graph it, just to give you an idea even before that, you are dealing with a function. And the way the rational functions work, they go close to their asymptotes. And of course, they may cross the horizontal asymptote or not. You have to check that. But basically, you have this one. You have this vertical asymptote. On the right side, you have 1 point. So this is the graph. And you can't have it here anymore because if you did, it would fail the vertical asymptote. And so it has to be on the other side. And the other side, it has to go like this or like this. Because we don't have any x-intercept, but we do have this hole, it has to go like that. But in any event, extra point, if we pick -2 here, we get -4, and 3 is -1, we get -1. If we pick -1, this becomes +1, we get 1. So we get those pairs. So this is the graph. Again, just to be on the safe side, this is the graph. Okay, sketch it, looking like that. Okay, so it covers those 2 points. It goes through this point, and there's a hole here. Again, without the hole would be this function. With the hole would be this function. X can't be -4 or the original function in essence. Given this function, find the domain and the rest of this. I'm going to graph this again, class. So to do so, we want to go through the process of finding the interval. X can be anything except 3, okay, because you set the denominator equal to 0 and excluded. So X can't be 3, and this is how you write it, from -∞ to 3, union 3 to infinity. The asymptote, the vertical asymptotes is very simple. Denominator equal to 0, VA, X equals 3. Hole, in order to find the hole, you have to find the common factor between the top and the bottom. There is no common factor, there is no hole. And so if you multiply these two, by the way, you get x squared plus x minus 5x minus 4x minus 5 in the numerator. The degree of the numerator is larger than the bottom. We don't have a horizontal asymptote, but we do have an oblique asymptote. We are going to do the division. Okay, so this is your vertical asymptote. There is no horizontal asymptote. And I'm going to leave it for you to do this. We've seen the synthetic division, so you should be able to do that. And this is what we do not need. Be careful this one. So y equals x minus 1 is the equation for the slant or oblique asymptote. We don't have any holes because there is no common factor between the top and the bottom. We want to find the intercepts. Okay, so that's your oblique asymptote. The oblique asymptote, you can pick up a couple of pairs. Okay, class, like 0, -1, and 1, 0. Okay, 1, 0, 0, -1. Just for the sake of argument, I can write the pairs at top of it. So 0, -1, 1, 0, those would be the pairs. So 0, -1 here, 1, 0 here. And again, it may not be too scale, but that's close enough. We want to find the intercept. So x-intercept and y-intercept. X-intercept, y is 0, y-intercept, x is 0. Okay. So for the x-intercept, we set the y equal to 0, f of x. And to set this equal to 0, we better use that. It's easier. So x-intercept, the top is 0. X plus 1 times x minus 5. So again, let me just write that. So x-intercepts, then x plus 1 times x minus 5. The numerator is 0. X is -1. X is +5. That means -1, 0, 5, 0. For y-intercept, you set x equal to 0. So this is 0, this is 0, this is 0. If this is 0, we get +1 times -5, which makes it -5. over -3 or makes it positive 5/3. So those are the two x-intercepts. And this is your y-intercept. Now, please understand that you have 1, 2, 3, 4. When you have two lines, you have 4 regions. This indicates this is the answer, and this indicates this is the answer. You really don't need extra points. Okay. So locate at least 1 point on each side. This is on each side of the vertical asymptote. This is on this side, this is on this side. So it tells you the graph practically. You don't need any more points. Those are good enough. F of x is x over x minus 2. Sketch the graph of f using technology to determine whether f is a one-to-one function. Of course, we've learned how to graph this, but just for the sake of argument, if we were to graph this, does it pass a vertical and horizontal line test? Yes. And therefore, it's a one-to-one function. It is a one-to-one function because it passes a horizontal line test. Now, if you have a one-to-one function, find f inverse and sketch a graph of f inverse. So let's go through the process. And so we're going to call this y to make life easy. We are going to interchange x and y. So this becomes x, this becomes y, this becomes y. This is how we find the inverse. And again, at this point, we do have the inverse. However, remember, we solve for y. To do so, we are going to do the following. I'm going to say x over 1. So the product of these two is y. The product of these two is x times y minus 2x. Remember, we are solving for y. So I'm going to move this one to this side to get 2x, this one to this side to get a negative y. I'm going to factor the y on the left side. I get x minus 1. So I'm going to divide both sides by x minus 1, and I'm going to call it f inverse. So that's the inverse function. And you can graph it again using technology. So notice a few interesting things. Vertical asymptotes and horizontal asymptotes. We draw this. We draw this. So vertical asymptote, horizontal asymptote. So this one, x equals 2. This one, y equals 1. By the way, if you look at it, you notice the denominator equal to 0. X equals 2. The degree of the numerator and the denominator are identical. So y equals the coefficient of the x at top over the coefficient of x at the bottom, y equals 1. So we have this one and this one for this guy. So x equals 2 for this one is y equals 2. Y equals 1 for this one is x equals 1. And by the way, if you look at this one, you can see that x equals 1 is the vertical asymptote. This is 2 over 1. Y equals 2 is the horizontal asymptote. It makes perfect sense. Let's look at the domain. The domain for this one, all real numbers except 2. We write it in this fashion, negative infinity to 2 union 2 to infinity. And that means the range for f inverse must be the same. So domain of f for the range for f inverse. So the range for f inverse is that. Now, how do we find the range of f and so forth? Look at domain of f inverse. Here's f inverse x minus 1 equal to 0. X becomes 1, and 1 must be excluded. So we write negative infinity to 1, union 1 to infinity. The domain of f inverse is the same as the range of f, so the same thing. So I hope you see how this thing works out. It's very easy. Use the domain of this and domain of this. Domain of this for the range of this. Domain of this for the range of f of x. That's very simple. Solve the following inequality, graph the solution set, and write the solution set in interval notation. 2. Solve an inequality without having to graph that, function. You have to factor the top and the bottom. The bottom doesn't need to be factored. The top becomes x plus 3 times x minus 6 because you want two numbers. The product is negative 18 and the sum is negative 3. If you set each one equal to 0, this gives you negative 3, this gives you positive 6, this gives you negative 2. Those are the three numbers on a number line we need. So again, this gives you negative 3, this gives you positive 6, this gives you negative 2. You put this in the proper order. So this is the number line, x f of x. We are going to call this f of x, everybody. I'm going to call this f of x. So f of x is 0 if x is negative 3. F of x is 0 if x is 6. What about negative 2? It's undefined. Undefined. So, by the way, they all have the multiplicity of order 1, so they alternate. All you have to do, pick a number and check it out. So you pick test points. TP short for test points. Of course, over here, the easiest would be 0, right? Over here, minus 2.5. Over here, like minus 4. So I want to go with the easiest one, 0. If I put 0, how do I do the evaluation? I just want to know whether I have positive or negative. This is what? Positive, negative, positive 3, negative 6 over positive. So I hope you see that this 0 results in negative here and the rest of them alternate. And by the way, beyond number 6, you can pick 7. So this is what you get. Now, so I evaluated this one. I want to make sure that you understand what I did. I looked at this one and the rest alternate. So if this is negative, positive, negative, positive. However, if you wanted to just plug in, for example, if I plug in negative 4 here, this becomes negative 1 or negative. This becomes negative 10 or simply negative. This becomes negative 2 or negative. So negative times negative over negative makes it negative. You can check the rest of them as well. Okay, so what does this mean? We want positive. So this place is the answer. This place is the answer. So from negative 3 to negative 2, union 6 to infinity. Is negative 3 included? We have the equality. Yes. Is negative 2 included? No, because it makes the denominator 0. So whether you have equality or not makes no difference. The denominator cannot be included. 6 is included all the way to infinity, and always infinity is not included. So if you were to do it on a graph from 6 to infinity and from negative 2 to negative 3, negative 3 is included, negative 2 is not. Okay, everybody? So again, a very straightforward. All right. Let's remind everybody about the end behavior of a polynomial function. The end behavior of a polynomial function is the behavior of the graph of f of x as x approaches positive infinity or negative infinity. The degree and the leading coefficient of a polynomial function determine the end behavior of the function. So the function in general is given a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 all the way to a sub 0. So this is of degree n. This is the leading term. This is the leading coefficient. And this will look like the leading term, a sub n x to the power of n. That's really the concept, ultimately, as x becomes extremely large or small. So here's what you need to know. If the degree is even and the leading coefficient means this one is positive, then ultimately looks like y equals x squared. But if it's negative, looks like y equals negative x squared. That's all. On the other hand, if you're dealing with an odd function, if a sub n is positive, looking like y equals x cubed, and if it's negative, looking like y equals negative x cubed, which means in this case, f of x goes to negative infinity when x goes to infinity and goes to positive infinity when x goes to positive infinity, and the rest of them you can read. But that's the concept known as the end behavior, the end behavior of a function. We also have behavior near zero. So the zeros have the following: x minus c to the power of m. If m is odd, f crosses the x-axis at c0. If it's even, it doesn't, it bounces back. Okay, so single zero, it crosses. Multiplicity 2. What matters is that the multiplicity is even. It doesn't have to be 2. Any even number will bounce back. This is multiplicity 3, it becomes flat. Okay. The higher the multiplicity, the flatter the curve is at the zero. The sum of the multiplicities is the degree of the polynomial function. And that's extremely important to know, everybody. We're going to graph the following polynomial using the end behavior and behavior near an x-intercept, where f of x is x cubed minus 5x squared minus x plus 5. So we want to graph this. And so the best course of action is to factor. So notice if I put these two together, I can take the x squared out. I get x squared times x minus 5. And these two, I just take a negative sign or negative 1 out. So it becomes x minus 5 times x squared minus 1. I'm assuming everybody's comfortable with basic factoring, and x squared minus 1 is x plus 1, x minus 1. We write all of it. And so what we have 3 zeros at x equals 5, at x equals negative 1, at x equals positive 1. And all of them have multiplicity 1. Okay, so that means when the function gets to those points, it just simply crosses the x-axis because the multiplicity is odd. Any number that is odd, of course, 1 is an odd number. All right. For example, we can see that the y-intercept, if you plug in 0, you get 0, 5, just as an example. And so the y-intercept is at 0, 5. N is odd and a sub n is 1. So it basically and ultimately looks like x cubed. So as x goes to infinity, so does y or f of x. As x goes to negative infinity, so does y or f of x. So x goes to negative infinity, f of x or y goes to negative infinity. Positive. So that's what we mean. And sometimes we just put these two arrows. So we put this arrow to represent that one and this arrow to represent that one. And the graph looks like this. Or that is maybe a better looking graph, a little bit more to scale. So to recap, you factor in order to see the intercepts because you want the behavior near x-intercepts. You pay attention to the degree and the leading coefficient. And of course, this is your y-intercept. So you find all of those, and you can come up with the answer. This one is given in the form we want. We don't have to um, factor. And please notice the leading term becomes 2x times x squared or 2x cubed. Ultimately looks like x cubed. So that we need that when we look at the end behavior. But first and foremost, the intercepts, x-intercepts, 2, comma 0, negative 3 halves, comma 0. Let's look at those. So the x-intercepts. And this one has multiplicity 2, and this one has multiplicity 1. So we have 2, comma 0 with multiplicity 2, and we have negative 3 halves 0 with the multiplicity 1. So when we pinpoint those, okay, this is negative 3 halves 0, this is 2, 0. What we do, we put an arrow here. That's what we use normally in calculus to represent the fact that the multiplicity is even, and whenever we get to that point, it's not going to cross. The graph will not cross. And so the next thing is to know this is 2x cubed. Okay, the y-intercept, by the way, the y-intercept. If you put 0, you get minus 2 squared of 4 times 3 is 12. So we have the y-intercept. The end behavior, this is 2x cubed. N is odd, and a sub n is positive or positive 2. So again, I would put those arrows. Those are referring to my end behavior, or one might say, as x goes to negative infinity, so does y or f of x. As x goes to infinity, so does y or f of x, and it will look like that. And this is perhaps a better graph with more to scale answer. What is the least possible degree of the polynomial? Write an equation for the polynomial graph. The answer is 4. Why is that? Because you have 1, 2, 3 terms. So we have one more than the number of terms minimum. By the way, the degree must be an even because of the end behavior. I'm going to write this. This is negative 3, everybody. So it's x plus 3. This is negative 2, so x plus 2. This is 1, and then we have this arrow, because notice what happens. It bounces back. So multiplicity 1, this one multiplicity even, and 2 will do the job. So we have x plus 3 here. We have x plus 2 here. We have x minus 1 quantity squared. And what comes in front, we don't know. Let's call it a. So we are going to write a, some number which we don't know yet, times x plus 3 times x plus 2 times x minus 1 squared. And all we have to do, use one easy pair to find the missing a. Obviously, you can see the y-intercept is located at 0, 3. And so replace all the x's with 0, f of x or y with 3. So this becomes a times 3 times 2 times negative 1 squared. This is 1, this is 6, so we have 6a. A becomes 3 over 6, or 1/2. And therefore, the final answer is the function is half of x plus 3 times x minus 1 squared times x plus 3 in any order that you write it is fine. Find the degree, leading coefficients, and the maximum number of real zeros of this polynomial. F of x is 2 plus 3x to the power of 6 plus 4x to the power of 7 minus 6x. Also describe the end behavior or long run behavior. So first and foremost, let's put them in descending order to make it easy to understand. So f of x is 4x to the power of 7 plus 3x to the power of 6 minus 6x plus 2. So it's easier to understand now. We know the degree is 7. And the leading term is 4x to the power of 7. So leading term is 4x to the power of 7. And that means degree is 7. And that means 4 is the leading coefficient. And because the degree is 7, the maximum number of real zeros must be 7. Because the leading term has a degree which is odd and the leading coefficient is positive, so 4x to the power of 7, n is odd, namely 7, and a sub n is 4, namely positive. So the behavior is just like y equals x cubed, which means as x goes to negative infinity, so does y or f of x. As x goes to infinity, f of x goes to infinity, f of x or y. So in other words, this really ultimately behaves like x cubed in essence. It behaves like x cubed in essence. So that's why we have this end behavior.